10.6, find segment lengths in circles. Today we are going to find segment lengths in circles. So in order to do these problems, we have to be able to solve quadratics. So this means I have to factor this. I need numbers that multiply to get 3 and add and subtract to get 4. So x plus 3 and x plus 1. That means x could be equal to negative 3 or x could be equal to negative 1. Okay? For the next one, I'm going to rewrite this. Okay? X squared plus 6x minus 9 equals 0, right? And that should be plus 9 because I messed this all up. This should be minus 6 plus 9. X was on this side. I moved minus 6x to this side, plus 9. So now, I need numbers that multiply to get 9 and add or subtract to get negative 6. It's negative 3 and negative 3. So x is equal to 3. Okay, now I want to solve this equation. So 3x plus 12, distributing, equals 4 plus 2 is 6 times 4 is 24. I'm going to subtract 12 from each side. I get 3x equals 12, x equals 4. And from number 4, I erased what I had so I could start up here. I would have 21 times x is 21x. 21 times negative 4 is negative 84. Equals 2x times x is 2x squared. 2x times 2 is 4x, minus 7x is negative 3x, and negative 7 times 2 is negative 14. I'm going to set everything here equal to 0 by subtracting everything on this side. Negative 3x minus 21x is negative 24x. And then negative 14 plus 84 is 70. I'm going to divide everything by 2. And I get x squared, factor out the 2, minus 12x plus 35. So now I need numbers that multiply to get 35 and add or subtract to get negative 12. And that's negative 5 and negative 7. So my x could equal 5 or 7. And my last problem here on the warm-up, if 10 is multiplied by 10 more than a number, the product is the square of 24. Okay? So if 10, I think I'm missing a step here. If 10 is multiplied by 10 more than a number, the product is the square of 24. That works because 10 times n plus 10 is multiplying, so they make a product. So 24 squared is 576. 10 times n is 10n. 10 times 10 is 100. 576 minus 100 is 476. Okay? I will admit I'm getting a little nervous here, so I just stopped the video, checked the answer because I don't know what the answer is, and I'm actually on the right track. So when I divide by 10, n, I get 47.6, which is making me quite a bit nervous. But that is the number, and let's check our work. 10 is multiplied by 10 more than a number. So 10 n plus 10. So 10 times n, which is 47.6. So plus 10. So that's 10 times 57.6 is 576. So as I said, I was nervous, wasn't sure I was doing this right because I was getting a decimal, but I was in fact. Have to trust the math, and it will all work out in the end. Chords intersect in the interior of a circle. Each chord is divided into two segments that are called segments of the chord. Okay. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segments of the other chord. So for instance here, EA times EB. I would call it AE and EB, but that's going to be equal to these. And then they go through how you could actually prove it. To prove this segment of chords theorem, you could construct two similar triangles, and the lengths of the corresponding sides are proportional by the cross products property. So let's see how that would work. Here I have two chords. I have chord ML and chord JK. So x times x plus 4 is going to be equal to x plus 1 times x plus 2. So x times x is x squared plus 4x. I FOIL that out, x squared plus 3x plus 2. Subtract x squared from both sides. I get 4x equals 3x plus 2. Subtract from both sides, and I get x equals 2. A secant segment is a segment that contains the chord of a circle. So instead of being a secant, which would be a line, it's a secant segment. It has exactly one endpoint outside of the circle. The part of a secant segment that is outside the circle is called the external segment. So if we have two secants, and they share, as we do here, and they share the same endpoint outside a circle, then the product of the lengths of one secant segment and its external segment. So one secant segment, that's the whole thing, E to B, times its external segment, is equal to the product of the length of the other times its external segment. I'm going to use this in a problem here to help you understand what we're doing here. So let's look at secant PR. The entire thing, I'm going to rewrite over here, is 9 times the external segment equals. Here, the entire secant segment is 3 plus x. And I'm going to multiply all of that by 3. So 9 times 4 is 36. I'm going to distribute that 3. 3 times 3 is 9 plus 3 times x is 3x. I subtract 9 from both sides, and 36 minus 9 is 27 equals 3x. So x equals 9. Okay? Now let's try that problem in a guided practice. So the external segment is 6. I'm going to multiply 6 by the whole segment. 6 plus 9 is 15. The external segment here is 5. I'm going to multiply this by the entire length of the secant segment, which is x plus 5. So 6 times 15 is 90 equals, that should be a parentheses, 5x plus 25. 90 minus 25 is 65 equals 5x, and 65 divided by 5 is 13. So x equals 13. And the next problem, this is not outside, this is inside. And I'm going to have to type because my slate just stopped working. Not good. So in this one, the chords, they're not secants, they're chords, intersect inside the circle. So to find the length, you'll remember that x times 3 is equal to 6 times 4, which is 24. So if 3x, that's actually how I should have written this, 3x is equal to 24, x would be equal to 8. And the next problem, this is an external one. That means that 3 times the entire length here, which is 3 plus x plus 2, which is x plus 5, equals, okay, in this case, the external segment is x plus 1. And I have to multiply that by the length. So I add those two together. So that's x plus x is 2x. Positive 1 and negative 1 is 0. So 3 times x is 3x. 3 times 5 is 15. X times 2x is 2x squared. 2x times 1 is 2x. This is going to end up being a quadratic when I have to get everything equal to 0 over here. So 0 equals 2x squared. I subtract the 3x from both sides, and I get 2x minus 3x is negative x, and I subtract the 15. So now I need to figure out a way, running out of space here, to factor this. This is going to be a 2. I think this should be a 5 and a 3. I think if I put a 3 here, 2 times 3 is 6, 5 there, that seems like that's going to work. It's a little bit of guess and check. So 2x times 3 is 6x. I need to be in negative land, so I'm going to put a negative there. That would be negative plus 5x would bring me to negative x, which would bring me, and 5 times negative 3 is 15. So now I have to set these each equal to 0. I know that x minus 3 means x minus 3 equals 0. X could be 3, or 2x plus 5 equals 0. If I subtract 5 from both sides, I get 2x equals negative 5. So x could equal negative 5 halves. So my answer should be 3, and x could equal negative 5 halves. In this case, though, x could not equal negative 5 halves, because if I plugged that in as a distance, even though some of you say, but you could use it as a number, when I plug negative 5 halves in, even like negative 5 halves plus 1, that's still going to be negative 3 halves, and I cannot have a negative value as a measurement in geometry. So the answer is just x equals 3. If a secant segment and a tangent segment share an endpoint outside the circle, then the product of the lengths of the secant segment, so ED times its external segment, is equal to the square of the lengths of the tangent. There's nothing else to multiply that tangent by. So let's try a problem and see how that would work. So RQ, 16. 16 squared is 256. So the external segment x times x plus 8 equals x squared plus 8. I subtract by 256. There is no ability to factor that. I have to use the quadratic formula. So my answers would be negative 4 plus 4 radical 17, or negative 4 minus 4 radical 17. I just want to see if both those solutions work to give me an idea. So, because some of you are going to be like, but there's negatives there, which I totally understand. So the square root of 17 is approximately that. Okay, so let's look at this. Negative 4 plus or minus roughly 16.49. So x can only equal the negative 4 plus 4 radical, because negative 4 minus 16 point, that's going to be like negative 20, and I cannot have a negative value there. So that's the only thing that will work. And they show it to you there. Negative 4, hold on, that was 17 square root 4, 17 square root times 4 equals that. I'm going to add that with a negative 4, and I get 12.49. And let's try to do a problem using this. So x squared, because that's my tangent segment, is equal to 1 times the length, which is 4. So x would have to equal 2. Oh, my guided practice problem was so much easier than the example they had me work out with it. And let's see what we have here. So 7 squared is 49 equals 5 times 5 plus x. 49 equals 5 times 5 is 25, plus 5 times x is 5x. So now 49, subtract 25 from both sides, is 24. So 24 divided by 5, or 24/5, would be the answer for x. So 24 divided by 5, if they wanted it as a decimal, would be 4.8. So the sound went out. We're going to have to use the quadratic equation. So negative 14 plus or minus the square root of 14, which is 196, minus 4 times a times c. So negative 4 times negative 225 would be positive 900. Because the negative 4 and the negative 225 make a positive 900. That's all over 2a. A has a value of 1, so that's 2. So 900 plus 196 is 1096. And let's see if that's a perfect square. It is not. So we need to start to try to factor to get this in simplest radical form. So negative 14 plus or minus the square root of 1096. I'm going to go over here to the side here and see if I can factor that. I'm going to do a little bit of guessing checking here. So I want to see if it's divisible by 4. That will make my life much easier. At least that's one perfect square. Divided by 4 is 274. And then 274 divided by 4 doesn't work. 274, let's think we could divide by 9, see if that works, because that's a perfect square. That doesn't work. 274 divided by 3, just to see, doesn't work. So it looks like 274 cannot be factored anymore. Oh, it can be. It can be divided by 2, I guess, but that's 137, I believe, is prime. So that doesn't help me out at all. Trying a few other things here, trying 7, till I decide that it must be 2 square root 274 all over 4, all over 2. Simplify, and I get -7. Technically, it would be plus or minus, but I can't have minus because that's going to take me into negative land, and I'm talking about a length, and that's not going to work. So -7 plus the square root of 274. And that was theorem 1016 that I'm using. But more importantly, I want you to know how to solve the problem. So in this problem, I can set this up. 18 times x is 18x. 9 times 16 is 144. I divide both sides by 18, and I get x is equal to 8. And for the next problem, determine which theorem you would use to find x, then find the value of x. So these are two secants that have the same external, two secant segments that have the same external endpoint. So taking the external length of the segment and multiplying it by the total length. So x times x plus 29 is going to equal 18 times 18 plus 22. And 18 plus 22 is 40. So x times x is x squared. X plus times 29 is 29x. 18 times 40. I already did 40 in the calculator, so times 18 equals 720. Clean that up a little bit. Video did some guessing and checking to come up with some numbers here. I believe 720. I think it's divisible by 16. I think that's what I found works. And 45. And 45 minus 16 is 29. So you could use the quadratic formula. So I did x minus 16, x plus 45. And so my x values would be 16 and -45. Since I cannot have -45, the answer has to be 16. And for the last problem in the diagram for theorem 1016, what must be true about EC compared to EA? So I've gone back and taken an image of EA there so that you can look at it and see if you notice here that EC has to be less than EA. For example 4, we have a real-world science problem like yesterday, lesson 10. So we have Tethys, Calypso, Telesto are 3 of Saturn's moons. Each has a circular orbit of 295,000 kilometers, roughly in radius. The Cassini-Huygens spacecraft entered Saturn's orbit in July 2004. Telesto is on a point of tangency. Find the distance from DB, from Cassini to Tethys. So once again, we're going to be squaring this tangent distance and then setting that equal to the external secant segment times the entire secant segment. And I believe the next page here is going to take you through that math. So as we said, we're going to set this up here. DC is the external part of the secant segment times DB is going to equal 203,000 squared. So 203 times 203 is 41,209. You would add 6 zeros onto that. So it's 41209 and 6 zeros. We're going to divide that by 83,000. And when we do this, we're going to then have to adjust our zeros. So remember, we should have had 6 zeros on that original number. So if I add 6 zeros on here, I'm going to have 496,494. So now for the daily homework quiz, round to the nearest tenth if necessary. They want us to find the value of x. So this one is pretty simple. 4 times 10 is 40 equals 20x. Divide both sides by 20, x equals 2. For this next problem, to find the value of x, we're going to multiply x by x plus 1, and we get x times x is x squared, x times positive 1 is 1x, and 18 times 4 is 72. Now we're going to subtract 72 from both sides to get x squared plus x minus 72 equals 0. Factor that. Factors of negative 72 are positive 9 and negative 8. Those also combine to give us positive 1x. Since our answers would be x equals negative 9 or x equals 8, we can't have a negative answer, so the answer has to be x equals 8. For our next problem, this is a tangent segment and a secant segment. So the tangent segment squared is x squared. 9 times the length of the segment. And 9 plus 16 is 25. Wait for my calculator to catch up. So 9 times 25 is 225. So if x squared equals 225, the square root of 225 is 15. While it could be positive or negative 15, it has to be positive 15 because it is a distance. So 18 times 45 equals 810 divided by 40 is 20.25. They said round to the nearest tenth if necessary. That's going to be closest to 20.3. And this one, they intersect inside. So x times x is x squared. 8 times 16 is 128. And they said round to the nearest tenth, so the square root of 128. So that's approximately 11.3. And then here you guys go. Here are the problems for your homework.